Thank you for coming. Just wonder if there was a show of hands. How many of you have heard of MariaDB before? Ooh. How many have used MariaDB before? Okay, one person. Okay, hopefully by the end of this talk, more of you would have used MariaDB. If you like this t-shirt, I don't have any t-shirts, but I have stickers that look like the t-shirt. So you can come grab some here after the talk. Okay, so I'm going to be here to talk to you a bit about MariaDB. I'm sorry I do not speak any Brazilian Portuguese, but I will say one word at the end. I'm Colin Charles from Monty Program AB. I do lots of things at Monty Program. We're a very small company. Only about 18 of us work there. We merged with SkySQL in April, so very soon I will be of SkySQL. I've been in the MySQL world for a very long time. I worked at MySQL AB. Sun bought us. After Sun bought us, I left because Oracle bought Sun. I've been working on MariaDB and MySQL for more than 10 years now. And before this, I used to actively work on the Fedora project, which is a form of Linux, which may or may not be popular here. And before that, I used to work on OpenOffice.org, which is now kind of dead thanks to Oracle. So the agenda obviously has changed a little bit, but it's got a bit of an introduction. I'll talk to you a little bit about how MariaDB is bridging the world between SQL and NoSQL, and how maybe we're also bridging the gap with something called NewSQL. And how many of you have heard of NewSQL before? Anybody using a NewSQL solution? Okay. So SQL has been around for a long time. It's been around longer than I've been on this earth, and possibly many of you have been on this earth. It became a standard in the 80s, and everybody knows SQL. Though SQL is hard to grasp properly because you also need to know relational algebra to some extent. So then came along the idea of rolling out cheap machines. MySQL was clearly one of the leaders that said you don't have to scale up, but you should scale out. This also brought forth the NoSQL movement. It was largely brought forward by two Google papers. One was the MapReduce paper, followed by the Big Table paper. And if you notice a trend, that it takes close to about 4 years before you get an open source solution based on one Google paper. It takes quite some time before someone says, this is a good idea, let's make some commercial products out of it. The problem with NoSQL is that there is no standard query language. If you use MongoDB, you have one query language. If you use Cassandra, you have CQL. If you use Hadoop, you have different query languages. The people at HBase tried to come up with something called UnQL that would work alongside SQLite and so on, but UnQL never went far. However, in today's architecture, NoSQL kind of works because you want it to be distributed. You want it to be horizontally scalable. You also want really, really easy replication because the cloud is here and it's not going to go away. People don't buy hardware anymore to start their companies and run the databases on them. I'm pretty sure everybody here knows the difference between base and ACID. Most of the NoSQL solutions are based on base, and generally you have different levels of consistency that you can get depending on the kind of solution you use. Cassandra has certain levels of consistency that will help give it even more consistency than just regular eventual consistency. Towards the end of 2012, Google published yet another paper called the Spanner paper. Has anybody read the Spanner paper? No. Okay. This is highly recommended reading because Google has moved a lot of their services from the regular MySQL world to their NoSQL solutions that had Big Table to something called Spanner. Spanner is new, Spanner is cool, But the most interesting thing about Spanner is that Google says, we want transactions back again. Working around transactions is a pain, and we really need transactions. The one thing that Spanner has that is very, very unique is this clock API. And it is currently it's a hardware-based API, so you can't quite replicate this with software. But minus the clock API, which is hardware-based, you can pretty much replicate all of this in something called Galera cluster that we ship. This is a map that was released in June 2013 by Matt Aslett from the 451 research group. If you are interested in open source databases, and you should probably only be interested in open source databases, there is a huge list of solutions out there today. There is no one solution. If you rewind back 10 years ago, you probably only had MySQL and Postgres to contend with. Today, even the MySQL world is fractured with MariaDB and Percona Server. There are at least 60 different NoSQL solutions out there addressing different portions of the space. Some do graph engines, some do big data, some do small data, etc. So, what is MariaDB? Half of you probably already know what MariaDB is since you said you've heard of it, but you're not using it. MariaDB is truly community developed. It has a lot more features compared to MySQL, but the one good thing about it is it always remains to be backward compatible to MySQL. So this means you can upgrade from MySQL to MariaDB and go back if you need to. It also really has a good ownership because the community contributes to MariaDB. I come from Money Program, where we only make up 50% of the contributors. The remainder of the committers, the code base, come from large companies like LinkedIn, Twitter, Facebook, Taobao. And we have a very active Brazilian contributor, not writing code yet, but he's definitely delving into code, Mr. Roberto Spadim. So we are always going to be 100% compatible drop-in replacement. There is no enterprise MariaDB. It is 100% GPL v2, which is probably very important when you're trying to roll out a database today. This is not like AGPL, which is something that MongoDB or even BerkeleyDB is currently licensed with, which is also something you have to consider when you start building network-based applications. And of course, they're same client libraries, though we have LGPL, C, and Java client libraries in case you don't want to pay Oracle for embedding it. Same client-server protocol, the replication is the same, the client is the same. The one difference that we have over MySQL is this cannot what happened to MySQL being sold cannot happen again because MariaDB is governed by a foundation. It's a not-for-profit foundation registered in the US. So the foundation says where MariaDB goes. MariaDB is like Linux nowadays, or an Apache project, basically. One of the cool features that we have inside of MariaDB is a modified InnoDB. Today, if you run MySQL at scale, be it at companies like Pinterest, Facebook, Twitter, you don't run stock InnoDB from MySQL. You're always running some form of patch set that came out of the Google and Facebook worlds. And in a commercial form, it's available as ExtraDB. In a commercially supported form, it's always open source. So when you say engine equals InnoDB, you're actually using ExtraDB. You have a lot more smoother checkpointing, as you can see from the graph at the bottom here. There is a better flushing to disk, more stable performance, especially when you have more RAM and more CPUs. MySQL, for at least the last, since 5.1, probably did not run very well when you had more than one CPU core. But keep in mind that MySQL has been around for a long time. Previously, we did not have more than one CPU core, and we did not have more than 3 gigs of RAM. We also have a thread pool. So if you are running at scale in the cloud, or even on regular hardware, a thread pool will help. Every time you open up a connection, your application opens up one connection, you're actually opening up one thread inside of MySQL. If you have very short running queries, you're going to hit thread contention very quickly. and this is a resource problem that can also get you to have out of memory and then get the killer to come along. So if you have very short running queries, turning on the thread pool helps because all you have is it'll open up maybe 20 threads and it keeps on reusing the threads over and over again. And this improves performance tremendously, as you can see from the red versus the blue. We use native thread pooling libraries, be it in Linux, BSD, or even Windows. And unlike the commercial version that you have to pay Oracle for, ours does not minimize concurrent transactions. We just build a queue around it, so we never ever reject queries. So any high bandwidth environment that generally has short running queries, think of pretty much every web app you have out there, will benefit from turning on the thread pool. The thread pool is one of those main features that also help messaging apps on mobile phones. So I don't know if you guys use WhatsApp or KakaoTalk, or there's an equivalent locally, but these apps generally benefit greatly from having a thread pool when you're having messaging queues and so on. We also make it a lot better for DBAs. We introduced a non-blocking client library so you can start operations in a thread, get results back from the thread later, and keep on sending more operations down there. This enabled the node.js people to build something called the MariaSQL driver. So if you are using node.js today, which is a high-performance JavaScript asynchronous language, which uses the V8 engine, you probably want a backing store, and the backing store is likely to be something like MySQL or MongoDB today. MongoDB probably makes more sense because everything's in JavaScript. But if you wanted to use a relational store at the back, the MariaSQL driver has amazing amounts of performance, as you can see up there. We didn't run this benchmark. This benchmark's available online for you to check. Every time someone mentions a benchmark, you always should check who the source is. But the MariaSQL driver is really, really fast. So if you are using Node.js, you should probably be using the MariaSQL driver even if you are using MySQL. Another cool feature, and you're going to start seeing these cool features as reasons why you may or may not want to be using a NoSQL solution, because we're starting to extend MariaDB to such a state where you can have the best of relational and non-relational. Group commit in the binary log. This, to have the D in ACID, which is durability, you need to enable sync bin log equals 1 and InnoDB flush log at transaction commit equals 1. This is, however, a very expensive operation, because every time there's a commit, you have to call fsync, and fsync is expensive. So what we do is we developed an algorithm that allows you, if you have more than 3 parallel running queries, to actually group that commit and have one fsync call. Thus, you can turn this option on and not see performance degradation during replication. We didn't do this benchmark either. This benchmark was performed by Facebook. And the green line down there shows MySQL. With more concurrent clients, its performance doesn't increase naturally because it doesn't have group commit. Facebook is arguably the largest user of group commit on the planet. And they have 2 versions. They made version 1 in yellow and version 2 in red. But the MariaDB group commit that we have is much better in terms of TPS with more concurrent clients, as benchmarked by Facebook. We also have progress reporting. If you want to alter a table or load data for your ETL operations, you probably want to know if this is going to take you 5 minutes or 3 months. If you've done this before, you probably know this is one of your frustrations and you said, this NoSQL solution is sounding better and better. This feature was actually built largely for Craigslist because they have such large archive data, and they moved all the archive data into MongoDB, but they keep the current transactional data inside of MariaDB. But when you want to run an alter table, when you have 16 years worth of archive data, it took them something like 90 days. that's unacceptable in today's world. Is everyone here aware that MySQL has storage engines? Yes, okay, pretty much everybody says so. Okay. MySQL is probably unique in the sense that it has pluggable storage engines. So your connectors, your application will speak to it, but then the on-disk format is always different. Storage engines have different capabilities, like they may be transactionally aware, they have different indexes, so you can get things like GIS working, and so on. We've taken the concept of storage engines and extended it so that you can now talk to other data stores. Storage engines can work over the network, as has been proven by the federated and the Sphinx storage engine. So we have a Sphinx storage engine that can actually allow you to do full text search queries directly to the Sphinx daemon. So we extended it further to allow you to connect to a Cassandra cluster. We also extended the replication API so that now using the binary log API in real time, you can now ship using the bin logs directly to a HDFS store so that you can now analyze stuff in HDFS. So there are now two different kinds of interfaces that allow you to get MySQL data, or more likely MariaDB data in the case of Cassandra, out into other databases. The benefits are enormous because your developers that know SQL can continue using SQL, while you can have other data stores and use the other data stores for different complex tasks, possibly. One of the first NoSQL features we included inside of MariaDB in 5.3, this was released sometime late 2011, was handler socket. We didn't invent handler socket, but handler socket was invented in Japan by DNA, large games company. And what handler socket allows you to do is it allows simple create, read, update, delete operations directly to InnoDB or ExtraDB, bypassing the entire SQL layer. So it goes straight to the storage engine. And this is a bit of an architecture diagram of how that happens. But with regular SQL, you can get about 105,000 queries per second when you're doing simple things like create or even reads. With memcached, we're getting 420,000 queries per second, but with handler socket, you're getting 750,000 queries per second on a relatively regular machine. In terms of user as well as system usage, it wasn't very high, so handler socket, well worth looking into if you just need to do fast create, read, updates, and deletes. However, it's written largely in Perl. Its data model is not as secure, so it's something you do not want to be running in an open environment. You want to run this in your data center. Another feature we included was dynamic columns. This also came in 5.3. This one allows you to create virtual columns with dynamic content for each row in the table. This is a blob with handler functions. You can do get, create, add, etc. You store different attributes from each item, and it's very, very hard to do relationally because a t-shirt and a laptop have different attributes, but your web store should be seamless in that sense. Dynamic columns is also the building block for us to have integration with the Cassandra storage engine. Dynamic columns is also an example of how we're going to allow you to now query and retrieve columns back and rows when you do a select statement to get data back in the JSON format. This is a building block to the future because we want you to not only be able to write SQL, but we also want to be able to write JSON because web developers today are really taking on to the JSON standard. Since MySQL 5.6, as well as MariaDB 10, you have the InnoDB memcached plugin. This is just an embedded version of memcached running inside that speaks directly to InnoDB or ExtraDB. You access data using the memcached protocol. It's the same put get stuff that you do with memcached, except now your memcached has a persistent storage layer in the form of a very reliable transactional store called extradb or InnoDB. If you are using PHP, the MySQL ND memcache extension is rather useful for this. You don't have to make much changes inside your application to make use of it. In fact, if you are using PHP, the MySQL ND MS is a really good driver because it does read-write splitting, it does sharding to some extent, and it's generally quite good. So we have to thank Oracle for making that driver and making it open source and contributing it to the PHP project. How many people here write PHP applications? It's a lot of you. Anybody using MySQL ND MS? Bunch of you. Excellent. I don't talk too much about NDBCLUSTER, and this is interesting because NDBCLUSTER probably was the first NoSQL storage engine that existed today. There was always a C interface to NDBCLUSTER, as well as a Java interface to NDBCLUSTER. NDBCLUSTER by itself was always a NoSQL solution that was brought into MySQL to have a SQL layer on top of it. Some of you may or may not remember an engine called Falcon, and Falcon itself was also a NoSQL solution that was brought into MySQL to have a SQL interface. So the idea of having storage engines that did not do SQL was actually quite common even in the past. Anybody here use node.js? Not so many. So besides the fact that you already have the MariaSQL driver for node.js, which you can get on GitHub, now you have node.js direct access to NDBCLUSTER as well as InnoDB. So you can do end-to-end JavaScript development from your web app directly to... Do you have a question? No. You're just raising your hand. Okay. So you can continue just using JavaScript even to basically make queries. So it's a storage layer that bypasses the SQL layer. Again, it goes straight to the storage engine. It also comes with an asynchronous interface because Node.js requires it. And this is currently experimental, but well worth a try. Again, we don't want to just bypass the SQL interface. We want to also make sure that eventually you can write JSON that goes directly through the SQL interface and then goes down to the storage engine. But this is a first example of how this can happen today. And this is available for work both done at Oracle as well as us. Anybody use Cassandra out there? All right. That's good to hear. With MariaDB, and this is unfortunately something you cannot run with MySQL because it makes heavy use of dynamic columns, and dynamic columns is not available in MySQL, but MariaDB only. If you happen to have a Cassandra cluster, we use the Thrift API to connect from MariaDB directly to Cassandra. So you can run your queries using regular SQL, not CQL, if you don't want to use it. And if you are already using one ORM for your language, you don't have to have now multiple ORMs that speak multiple languages. There are great many use cases, but nothing that comes out of the box today. One of it could be collecting sensor data into Cassandra and then doing relational stuff with it inside of MariaDB. If today you want to do log collection, MySQL and MariaDB are very bad for doing this. I mean, streaming data is not something a relational database is good at doing, but it's something that Cassandra excels at doing. You can do real-time analysis. You can do real-time tracking of a user on the web page. So if you have a user on your main page and the user clicks to go somewhere else and goes somewhere else, you can actually use Cassandra to get the real-time tracking using the Cassandra storage engine rather than using just InnoDB and then querying it later. You get real-time data, so you can now offer your customer, possibly in an e-commerce shop, more options if you know how he or she has been traveling through your website. So user activity tracking, while it sounds creepy, is something that more and more people are doing as people collect more and more data. And if you have more data, you can make use of it, especially if it's real time, and it could affect transaction value. If you are currently using MySQL or MariaDB and you want to have a globally replicated table quickly, and you want it to be fault tolerant, it's a no-brainer to use the Cassandra storage engine as well, because Cassandra handles this automatically. In the MySQL and MariaDB world, you have to build these topologies manually. And this is one of those reasons why NoSQL databases are becoming relatively popular today as well. This storage engine is in production in several places now. Telcos are interested, e-commerce shops are interested. It's well worth looking into this further. We also included another storage engine called the Connect storage engine. So engine equals connect. The Connect storage engine speaks XML, which is not so interesting to many people, one would presume. But the other thing that it does is it speaks ODBC. And via ODBC, you can connect directly to Oracle. And you can use MariaDB as your intermediary to connect directly to Oracle, SQL Server, anything that supports the ODBC standard, and join with other MariaDB tables as well. And since MariaDB now is an interface to other storage engines like Cassandra and Hadoop, like via HBase even, you can join Oracle data with HBase data and save the result set inside of InnoDB. This is now possible and not rocket science any longer. So again, we're aiming to be like a data platform that allows interchange of data. Since we cannot fight the NoSQL movement, we might as well join the movement. JSON is going to play a really important role. Already, I mentioned that we have JSON coming out of dynamic columns. Explain also provides JSON output. Today, you have two tools called MySQL JSON import and export that are external that allows you to do JSON. It's similar to MySQL dump, but get stuff out in JSON. I don't know how many of you know that we've had XML support in MySQL since 5.1. 5.1 was released in 2008, I think, possibly. So, or maybe even earlier. And that means that XML support has existed for a long time. JSON seems to just be more popular and more palatable than XML. And in future, we want a JSON proxy, so you can totally write queries and get result sets back in JSON. So we will have a JSON layer available for you. Anybody here use LevelDB before? Okay, one person uses LevelDB. Anybody here use the Chrome web browser? Pretty much all of you. Okay, so you're actually all using LevelDB. Inside of IndexedDB, for the HTML5 storage, LevelDB is embedded inside of all your Chrome browsers. LevelDB is developed inside of Google, written from scratch as a key value store, but then it's taken on its new life. Not only is it embeddable inside of Chrome, it does many other things like having crash-proof slaves, great replication, non-blocking schema changes, and so on. So much so, we have a storage engine for LevelDB that works against MySQL 5.6 or MariaDB 10 out today. LevelDB, alongside WiredTiger, are very popular upcoming key value stores, though I think LevelDB seems to be even more popular than WiredTiger. And it's fully open source, written by Google. There's a paper to boot to go with it. So we have a LevelDB interface as well. But that wasn't enough. We thought, why don't we have a HBase interface? Anybody here use HBase? Hadoop? Oh, they're at the back. Okay. So, HBase and HDFS is awesome. So the replication API can write directly to HDFS. However, if you use HBase on top of it, we're looking very closely at integrating Honeycomb, because HBase can do things like automatic sharding, replication, failover, etc. Honeycomb currently exists that allows you to query your HBase directly from MariaDB or MySQL, to be fair. You can do MapReduce, and you can do pretty much any transaction you want with HBase using the SQL interface. The current very alpha version has about a 25% performance drop compared to directly reaching HBase. However, once we turn on engine condition pushdown and tune the engine, as in before we release it, we expect to have next to negligible performance loss, just like we have negligible performance loss in terms of using Cassandra and so forth. In fact, when we use Cassandra as a backing store, benchmarks have shown that using just InnoDB as a backing store versus using Cassandra as a backing store, we have much greater performance with Cassandra as a backing store. So we expect similar with HBase. So this is currently under active development. I'd say it's about 80% there. We have some work to do, but expect this to be useful very soon, around September. So to recap, we have a lot of connectors today that connect to many different databases. We want to really be that platform that allows you not to migrate to another database, but to use another database side by side, be it a NoSQL store or a SQL store. But what's really wrong with MySQL, and by this vein, what's wrong with MariaDB? Out-of-the-box high availability sucks. With MongoDB, you can have easy replicators, great failover tools, and so on. With MySQL, you need to know that MHA exists to allow automatic failover, for example, or use the MySQL failover tool. Not many people know these tools exist. Multi-master replication is completely missing, and if you tried MMM, you will shoot yourself in the foot eventually. The real answer to this is global transaction IDs, which we have in 5.6 and MariaDB 10. Out-of-the-box high scalability. Today you want to scale up and scale down in the cloud. If you don't integrate with RightScale or Scalar, Scalar is the open source version of RightScale, you are not going to go far. You can't build these things yourself. Also, synchronous geographic replication is lacking with regular replication. You can make different replication topologies to have asynchronous, but there just isn't synchronous replication unless you use NDBCLUSTER. But we have a solution for that. Oh, sharding. Sharding is really difficult. Everybody complains about this because there's so many different ways to shard your data. And if you were in the track earlier, there was, I believe, a talk about partitioning and sharding potentially by the chap from Microsoft, though I could not understand it because it was in Brazilian. So I presume you have the base of this. But with regards to MySQL, you could either use your own framework, which is what most people end up doing, and possibly shooting themselves in the foot, or using the Spider engine, which we are integrating for vertical sharding. You can use Tungsten Replicator, which is open source, and used in companies like Box.net, which is like the enterprise Dropbox. Then you have Tumblr Jetpans. Tumblr just sold to Yahoo for like $1 billion, and they created their own sharding framework called Jetpans in Ruby, which is probably the best solution out there today that will not shoot you in the foot. And then there's Shard Query, which splits your queries and puts them on parallel to shards. So sharding is another problem with MySQL. It's the know-how that one needs to know. Online schema change, I mean, what world do we live in when you can't do online alter table? This is a huge problem with MySQL, and it's been fixed. But this is also what gave rise to a lot of the NoSQL solutions, because nobody really wants to wait 3 months to alter their table with live running data. Today you can use external tools. I highly recommend the OpenArc toolkit or the Percona toolkit online schema change. The Facebook tool also exists, but it's not supported by anybody, so use at your own risk. So with all those problems, and keeping the new SQL idea in your head, minus the clock API, I'd like to introduce you to MariaDB Galera cluster, also available as Percona XRDB cluster, or just CodaShip's Galera cluster. 3 companies ship the same product, basically. Galera cluster allows great high availability and scalability, comes with synchronous replication. So your transaction will be committed to all nodes, not just one, but all. You also have multi-master replication support. You have parallel replication. And all slaves are always synced. You can load balance in the front with HA proxy. And this is great today for cloud environments inside of AWS. And I think the most interesting fact of all of this is the backing store of all of this is not NDBCLUSTER, which is something many people don't know. the backing store is InnoDB, which is something everybody does know. So today in your cloud environments, and we've extensively tested this inside AWS to reduce network spikes and basically all the sawtooth and the jagged network performance you can get sometimes when you run queries across. And if you manage to run a Galera cluster inside of one availability zone, say Sao Paulo, you then replicate using maybe MySQL replication to another availability zone, say US East 1. And then inside that, you'll have your own Galera cluster. You actually have geographic replication built into MariaDB Galera cluster. And this is a completely open source project as well. It is an easy way to scale your application, and it requires next to no changes in your application either, because we've run this with WordPress in the front, we've run this with Drupal in the front, and basically you're just scaling out your reads and your writes with Galera cluster. This technology has been around now for at least a year plus. It's been around a lot longer, but the GA products for it, after a lot of QA, has been about a year. And it has customers that exceed more than 100 that are commercial customers. So we can assume that there are a lot more out there that are non-commercial as well. And it's got a lot of good support from many large companies as well. MariaDB is deployed in many, many places. I think the most famous one that I can tell you from South America would be OLX. I don't know if OLX is something you're familiar with, but they power classifieds for many websites, including Friendster and so on. Paybox services is e-commerce in France. About 30% of all credit card transactions in like your taxi or in a store go through Paybox, and that goes through MariaDB. Wikipedia, I'm pretty sure most of you know Wikipedia, and Wikipedia made a big fuss about moving to MariaDB in April. Craigslist may or may not be popular here. They run MariaDB and MongoDB together. Mozilla, so for the people that are still potentially using the Firefox web browser and not Chrome, Mozilla moved a lot of their servers from Percona to MariaDB. And they have got some interesting words to say from the developers. Web hosting companies generally say they get more use out of MariaDB running on a machine. A website called /gear says they saved a lot of money in the cloud thanks to using Nginx and MariaDB. So generally people say they save money with MariaDB, and if you're already using lots of cloud resources, isn't it nice to save money? Getting MariaDB is very easy. You go to mariadb.org and you download it. Simple. It also comes with pretty much all popular Linux distributions out there today. So it's also this year become the default in distributions like Fedora, OpenSUSE. It's coming in RHEL 7, most likely as a default. It's available in RHEL 6 via software collections. Many software packages mention MariaDB as well, so give it a go. This is one of those problems with NoSQL solutions, is that many software packages do not support them out of the box. Many of the popular software packages today support basically MySQL, so you really need a better MySQL to scale. It's not until Drupal 8 that you'll get MongoDB support inside as well. Anybody familiar with the Percona server branch? Okay, a bunch of you are, not so many. Compared to Percona server, we have a lot more lines of code. We have over 61 megabyte diff today, and about 1.5 million lines of code extra over MySQL versus, say, about 400,000 in Percona server. So we are a superset of Percona server. So if you're already familiar with Percona server, you definitely want to take a look at us as well. We've got a good track record security-wise. We found bugs that allow you to, if you run random logins, this was a big bug last year. Within the first 300 tries, you can definitely get admin access to MySQL. So we fixed that. We dislike regressions, so we have a great test suite to ensure that when a feature makes it, it doesn't break an old feature. This is important to all of you who are using something like RDS, where you don't have control over minor version upgrades. And minor version upgrades can cause InnoDB regressions, can cause the query cache to be disabled for partition tables, and so on. And we really, really care about introducing features carefully. So we didn't have the reflex method for a long time because it was basically a bug. And we didn't want to introduce a bug, which was removed from Percona server after about 4 releases as well. So we were very, very careful with what we do. We obviously care a lot about quality. And if you want to see test cases, we outnumber and outstrip the amount of test cases that exist in all the variants of MySQL today. Also because we have a lot more features. I think in conclusion, generally, I'd like to say you should use the right tool for the right job. Don't just choose something because it's cool or this site uses it. I mean, the old adage is, oh, this Google uses this, it must be right. If Facebook uses it, it must be right. Well, all those large websites, if you follow those, if X is using it, it must be right, have been running relational databases for a long time. But NoSQL has many, many uses. So I'd suggest you study SQL to the extent that you cannot use SQL, and then you find that you've already reached the maximum capabilities of SQL, and now it's time to start using NoSQL. So if you're building Twitter today with streaming messages, relational database is not right for that. You should definitely go for a NoSQL solution. But don't start with a NoSQL solution, say like MongoDB, and then reach a scale where you then need to migrate off to a relational database like Postgres or MySQL, because that hampers your growth. So use the right tool for the right job. I think that's probably the most important, and know all the limitations for SQL before you move to NoSQL. And in the event that you do need to use SQL and NoSQL together, that's what MariaDB is for. You can define the future. We're obviously looking for more storage engines to write. The first one that we thought of doing was MongoDB. We also heard that Solr is pretty important from the libraries and archivists of the world, as well as the Drupal users. We have Sphinx as a storage engine, so we're not sure how important Solr is, but this is something we'll definitely do. We've heard Redis is something that's also potentially important. We've also heard for Neo4j. We're looking for at least 2 of these solutions for next year because we've already integrated all the other NoSQL solutions. But we have also got a graphing storage engine called OQGraph. So we have many different storage engines. It's just how you end up using them. And I'm sure that there are probably more NoSQL solutions out there. People have suggested CouchDB as another option. But we've not really got enough users to say, hey, we like CouchDB. So if you tell us you want something, or if you want to write something, it's an open source project, so feel free to join us. I have a huge list of references here of papers you should read, and I'm guessing that you will all get these presentation files possibly on the website or something, failing which it'll all be on SlideShare. I highly recommend that if you are interested in the database space, to read the Google research papers, the MapReduce, the Bigtable, and the Spanner. There are 3 really interesting ones. MapReduce and Bigtable is what's shaping today's NoSQL world. Nobody has actually picked up on Spanner and made something like the clock API. But with things like hardware getting cheaper and people getting more access to things like Arduinos and Raspberry Pis, maybe this clock API and shipping hardware with software can work in the future. It's very hard to say. But in terms of MariaDB, we're lucky in the sense that we have everything via Galera cluster minus the clock API at the moment. We're also incredibly social, so if you are on Facebook, like us. If you're on Twitter, follow us. If you're on Google+, say hi. And I may have time for questions. It's supposed to end at 3 o'clock, so my clock says I have 2 minutes left. So, obrigado. So, does anybody have a question? Oh, I have stickers to give away as well, which you can get on your way out. Anybody with a question? Hmm? Yeah, I'm sorry.
Okay, so his question is, where are you from, and how is the market for MariaDB where you are?
Okay, so where I'm from, I forgot to mention that, but it was on the second slide, I think. It had a flag. It was a Malaysian flag. I'm from Malaysia. Is the market big in Malaysia? I'm not actually sure because I don't spend much time in Malaysia. Most of my time is spent in the US, Europe, and in parts of Asia like Korea and Japan, where MariaDB is growing greatly. I get to come down to South America maybe twice a year. So this is my second time in Sao Paulo. And we've also been quite big in Buenos Aires in Argentina. In terms of market share, analysts say we are clearly gaining. So again, we go back to the 451 research group that says that by 2015, the whole MySQL market alone should be worth in excess of several $billion. And MariaDB is the one that's actually growing. MySQL is currently on a decline because of various reasons, one of which is the owner is Oracle. But to be fair, I mean, Oracle's not a bad company. They're doing, wonderful things with MySQL. So, and the other thing maybe is that, NoSQL solutions are becoming popular, but there's no real one big NoSQL solution. If I had to pick one, I'd say MongoDB is probably the biggest NoSQL solution out there. So is MariaDB big? Yes, it's growing. Is it as big as MySQL in terms of download numbers? No, not yet. But we have our first book, which was written in 2010. So MySQL got its first book 6 years after we released. MariaDB got its first book about 1 year after it got released. So we are clearly on a different growth path. Are we as big as MongoDB? No. But being in the Linux distributions as a default should help our growth tremendously as well. But back to your original question is, yes, I'm from Malaysia. Is MariaDB big there? I don't know. I'm hardly there. But it's possibly big elsewhere. And from our user base, we actually have a user stats tracking tool. If you go to mariadb.org, you can see the feedback plugin. Brazil actually ranks pretty high on the feedback plugin. We have I think Indonesia might be the top country, which is near Malaysia. But Brazil probably is number 4. The US is, I think, number 2, and China's number 3, and Brazil's number 4. So it's quite big in Brazil, except I don't know enough users to tell you more about it besides, say, OLX. Yeah. Any other questions? Yes. About global transaction ID, does MariaDB work? Yes. So there's 2 versions of global transaction ID today. The MySQL 5.6 version, which is known to have lots of bugs. And MySQL 5.6 is GA, so there are many bug reports made against it. And the disadvantage of global transaction ID in MySQL 5.6 today is the simple fact that for you to start global transaction ID, you have to restart all your servers at the same time. If you're in production, that's pretty hard to do. You can't just restart your slaves and then restart your master. That doesn't work. So we took a different approach to doing global transaction ID. And this approach, if you follow the mailing list, is the approach that even the folk at Google like quite a bit. So yes, we believe that our global transaction ID works better than MySQL's global transaction ID. And currently we're also working, since the global transaction ID is out inside the alpha software, we're also working on the parallel replication to be better than the 5.6 one. And if you follow the mailing list, it's quite clear that there are many Google engineers very interested with MariaDB. I can't tell you why, but maybe you can guess from the mailing list. So yes, we definitely have GTID that works better. We will parse GTID from MySQL 5.6, but if you have GTID turned on inside of MariaDB, because we use a different protocol, we should not be able to parse back to MySQL 5.6 because it will not parse the new GTID. But we will definitely parse 5.6 GTID, which is currently what we do. And yes, our GTID definitely works. Try it. If you have a bug report, file it at Jira or join the mailing list where you can interact with our engineers, the Taobao engineers, and the Google engineers who are very interested in GTID. And the continuant engineers as well, because they build Tungsten Replicator. Any other questions? All right, if there are no questions, I'm done. Thank you for listening. Obrigado. Get your stickers.